Hello together. Today we will learn how to program OpenThread with the nRF Connect SDK. I will split this up in two videos. So today we will make communication via the command line interface, which is quite easy, and I only make a short introduction into Thread again. There is another video already where I explain it in detail. So take a look at this video first. If you don't know what Thread or OpenThread is, I will also put a link into the description. Short overview: Thread is an IPv6 based mesh network technology and suitable for home automation and sensor-actuator applications. Has low power consumption. You can have sleeping device, for example, and the specification is free accessible. It's founded by Google, Google Nest, Osram and Samsung, and also Apple joined already there. It's based on the IEEE 802 15.4 protocol and has no single point of failure. So we can, with Thread, we can build up our mesh network. You're seeing here the layers from Thread. We have here the two downer layers, the IEEE specification standard, and Thread are the two layers above it. So it supports 6LoWPAN, IP routing, and UDP, so the communication. And on the top, OpenThread also implements, as we have, for example, core app, which we can, where we can communicate then or exchange data. The downer part is for direct communication, wireless communication without any routing, and Thread add to this mostly the routing part. Here you're seeing example network. Yeah, we're having the different kind of nodes with different roles. Normally we're having routers, yeah, the red one, and end devices. The routers can forward traffic, and an end device always belongs to a router. And we have also a thread leader. This is this one who maintains the airlock. It's called the routing ID for the communication. He gives it to the router which connect to the network. So we're having there quite simple routing algorithm. We have also here the possibility of a border device, border router, which can then directly communicate via IPv6 or IPv4 with the internet. There's also another video available how to make a border router. I can also take a look at this. To use OpenThread in Zephyr is even easier than in an nRF5 SDK before. We need for the example here two developer boards, and also we start again with our Blinky example. Yeah, make a copy of it and rename it my Thread CLI example, and delete like normal. So build, start in Visual Studio, make the add the project, there, and adding a build configuration. When the build is done, we can directly start, and we don't have to make so much for implement the OpenThread into our program. But we have to add some modules in the project conf, and there we're needing quite a few parameters. I will make this also with copy and paste. The first thing is we have to enable the OpenThread features, the Nordic libraries. We are using it for full function device, so can also make an MTD on FTD, and even for border routers, the whole functionality. You can check this, I think, when you're typing in config OpenThread and thread Nordic. You're seeing here, you're having here MTD, FTD, and master. But for this is okay, so FTD. And we are then also enabling L2 OpenThread. This is modules for OpenThread. And also configuration for networking, so generic networking operations. Then after this, we are adding the network parameters. We can set them also with API functions later, but this is quite comfortable to set it here as a network parameter. So I make here config OpenThread manual start to know. If not, I have to via command line interface to start it manually. It's more convenient that it's using the parameter here and I don't have to set it, so I set it to no. And we can set here a network name like VSN, for example, wireless sensor network. You can choose a PAN ID. The PAN ID can be between 0 and 32,200, yeah, a little bit. And there we can set the PAN ID, the extended PAN ID, which is 64-bit. This here is 16-bit. Yeah. And what is also important, the network key for encryption. I use here the common standard network key. This is not safe, but we can easier than remember this and later sniffer with sniffer stick, for example. But when you want to make it secure, of course, you should exchange this key. Then for the command line interface, we are adding a shell. Yeah, there can be multiple shells in Zephyr, so not only one, so we have to activate the shell at all. And then we are activating the OpenThread shell, and with a few parameters which size the shell has with buffer size. After this, we are setting a few additional parameter. This here is for efficiency is hash algorithm SHA-1 and also float point unit. Yeah, these are the settings for the configuration file. And after this, we have to adjust one thing in the overlay file. I do not know if it's really 100% necessary, but in all the examples, the Nordic example does it too. So we have to make an overlay file. Here, now we have the overlay file. Don't know what sometimes happens. And we have to set here chosen entropy. Yeah, what this does, it's a random generator, and I don't know why we have to use this one and not the default one. The default one is CryptoCell, and now we have to choose a random number generator. Maybe it's necessary for any process in OpenThread, so I wouldn't change this as long as I don't know what it's doing 100%. In the whole example, it's also set to this. Yeah, and this is actually already the main process, and our application is actually quite simple because we don't need anything. We just can delete the whole application and just make a while. Here I also, the whole process, I let the sleep timer inside, GPIOs, so, and yeah, so that we can program something later. And after this I start the building process, and this will now take a little bit. The building process took quite a while, with my computer around 5 minutes. Depends of course how fast the computer is, and every time when we're changing something on the project configuration, it will again take as much time. And when we're making a pristine build, then this is all built new, then of course too. I connected now 2 devices through my computer. You're seeing here, we're having here labels on the chips. These are the labels which we're seeing here on the connected devices. Yeah, so be careful that you don't bring it, that you don't mix them. I also make a label like 1 and 2. This is the end of my serial number here from the chip. And first we transfer the firmware now to the boards. We're going here on flash, but be careful, especially for the first time when you flash something, set your reset before. So don't go here on flash, go on erase and flash. That the devices, also the parameters from the thread stack or something before is deleted. I do this for the second device too. Flashing here, wrong one. Flashing the second device and transfer to this developer board also. And now here is also terminal window. I mean, we have to communicate with the shell via the UART. But I don't use now the virtual COM port the terminal here, because we can only use one at the same time. At least I didn't find out how to make it different. So for this I'm using PuTTY. PuTTY is a telnet client which you can download from putty.org, and you have there to set the parameter also 115,200 and the parameter flow control off, parity bit off, and stop bits to 1. These are the default parameter. I just start PuTTY with the first developer kit, and when I hit here enter, you're seeing I got a prompt here. Yeah, it's like a shell prompt. And this prompt we can use the command line interface from OpenThread, and there are different commands which we can use. There is a list from all the commands. Under this link you get the list of all commands. For us at the beginnings are important what state the device have in the network, what IP address, and how the network parameter are. And we're making this over these commands. Now, since there are different shells possible in Zephyr, we have always to use the command OT before for OpenThread, that it's OpenThread shell addressed. Yeah. So when we want to get the state, before we could only use state in the nRF SDK. Now we have to type in OT and then state. So we will try this, OT and state. And we're seeing here that this is the child. And when I look at OT IP address, then we're getting the IP addresses from this device, and also OT data set active. We're seeing here that our parameter which we set in the configuration before are set. When I make OT a state, maybe it changed. Yeah, now it's already a router. Yeah, so this means the other device is then the leader. And I open also a second putty. And checking here, OT, state, and this is the leader. Now we want to send from device 1 to device 2 an UDP packet. This works over the command line interface similar like before, except that we have to put the command OT always in front to address the OpenThread shell. Yeah, first we are checking the IP address from the first device, then we open UDP, then we bind it to all IP addresses, so we accept from all IP addresses a package and listen to the port 1, 2, 3, 4. And on device 2 we have open UDP also, then send on the IP address from device 1 and support 1, 2, 3, 4 and the text hello. So we're starting here, OT, IP address. We're using this IP address. Yes, this is a unique one. This is a router IP address. We don't use this one. This is for routing purpose. And this is a link layer IP address. Yeah, so this is the right one. Then we open UDP. UDP open. And then we bind UDP ODP. UDP bind. 1, 2, 3, 4. So, and the second device now we open UDP. OT UDP send. Now we have to copy the IP address here. This is always a little difficult. So, copy. Then we put it here inside. Send 1, 2, 3, 4. And send the text hello. And we're seeing that this message arrived here. When we're doing it again, it will also happen again. So we're seeing we can successfully transfer a UDP package. This was the first introduction into the OpenThread in Zephyr and how to use it as basic example. Of course, to using the command line interface only, it doesn't help us for programming anything. So we need to know how to make this over the API. This we will do in the next video, how to program to send a UDP package over the API, and then taking also a look into the core app part. This was it for this video. If you like the video, don't forget to push the like button and see you in the next video.